Okay, so this should be going through. Okay. So here we have, let's just go to the beginning here. First. Oh man, I had to explain all this. So, this is, I'll start with this. This is the driver area. This is the driver circle itself. That is that circle. That is the ring the driver fits in. It should fit in. But it turns out there's a glitch. Watch what happens when I try to change this to 43. Failed to solve, even though it clearly should be able to solve it. So here, what is this one? Oh yeah, that's that. So that's the pad area here. Right here, where that's highlighted here. Yeah, there we go. Now you can see it. This, that, this little area in between, and that area. That's the area that will clip onto the band this sits on. Here's a little circle for a fillet, so I don't, because one of the extrusions is gonna come up to here and get non-manifold at this point. Right there. So now, here are all the ribs. Here's openings. Here's the bottom of the main resonance, main acoustic cavity. Here's the edge of the acoustic cavity. There's more driver mounting area. Those are the ribs that hold the driver mounting area in place. Now let's go next. Go to the next one. Next step. Next step. We extrude this little thingamabob. Note how I use the circle up here to make it not go to 0 thickness at that point. Right there. Next step. Nope, that was... There. Now this gets extruded thinner. That was 6 millimeters before. This is 2.5, I think. Yeah, 2.5. And there we have our basic shape of with all the holes and then the driver hole. And then go here. Those fillets for strengthening the holes. Here we start to make the this driver mounting area. There we have the lip the driver rests against. There's the lip it rests in, and then a little lip inside that to rest against, to give it a stop to get its position exact. Then that lip and all this, we put a chamfer here to reduce the number of corners that are right by your skin. Make a new sketch. Let's look at what it looks like. And this sketch starts figuring out starts laying out the way to bring those ribs and pull them out, but more in the middle than the outside, so they taper some and all that good stuff for strength. And there we go. There's the sketch extruded. Next step, chamfer there. Next step, chamfer Where was that? Here. And boom. What? Okay, then we chamfer that because the driver needs to have a not be so tight right when it goes in. We chamfer that, then we chamfer that, then we chamfer that. These are uneven ones, so they're not 45 degrees. They're different angles for each one. That's why I did different operations for each. Then we round off all those corners there. Then we do a bit of rounding on that corner, a bit of round, another chamfer on that corner because we can. Yep. Here we finally get around to rounding this corner. Way the heck over here. Where was this one? Oh yeah. Yeah, more or fewer sharp corners by your ears there. What's a sketch? Yeah, we start to make the clip. And the base that it's going to print on. There we go. And another sketch to make that little piece. And fill it the inside here so it's round because the top of the band is round. Band is still made of solid plastic though. Chamfer that. Fill it where? Oh, fill it around there. Right on that. Let's see if I do this. There. Round off that edge. And that edge. And that edge. Ah, there we go. Here is the border of the acoustic cavity. The wall, the side wall of the acoustic cavity. But we don't want a straight section there. We don't want a flat back on the acoustic cavity because that makes all kind of weird resonance. So we do that. That's just our work plane. I added it in to make things work later down the line. You make a sketch, extrude, a sketch like that. Fill it. Where was that? Oh yeah, around all the tops here. What was that? Yes. We fill it around all the tops here to make them not sharp. Acoustics this time, rather than ergonomics. Make another sketch. What I did here was I projected a plane so that I could extrude starting at this. Well, it's not a plane, it's a curved surface. So I can extrude starting at this curved surface and go from there. Like extrude a set distance from there. And there you see me doing it. With this body, which for the purpose of this, I'm going to go solid. So there's the back plane of that. Back plane of the back piece, the cover for the acoustic cavity. That's what I forgot. A wire hole. Yeah, I can add that later. Yeah. Do I even need it? Yes, I do. Okay. I just realized I didn't leave a hole for the wires to the driver to get out of the acoustic cavity. Silly me. Have to know what size the wires are first, I guess. Then we extrude down the outside. So it looks a little. So took that, pulled the edge down that way. Then chamfer what now? Oh yeah, inside there. I really have to get in there to see it. But let's look right at that angle. There we go. Chamfer that so that it can go on. Fill it. Where the heck? Oh, those corners. See, then those corners get rounded. And then we split it right here. Because I realized at this point, if you go like this, there's going to be a pad on this face. That's highlighted right there. There's going to be a pad on that face. So that pad's going to have thickness, and that band right here sits right against your head. Well, it's not going to work if it's not going to fit right if I do that. So the next step is just move that over after we split it. Then I draw a sketch, delete a face, draw a sketch, extrude it to make this more natural looking. Delete those curved faces there, and then it repatches itself. Advanced operation, sort of. And a sketch to extrude the bottom half of the clip, finally. Sketch, extrude the part that connects them. And fill it, fill it, fill it. Round off all that. Now we extrude the rim that'll give me a reference for where the heck I'm supposed to put this pad exactly. Maybe a mounting for the pad later on. Excuse me. So here we have this. Give me a sec. Here have this just. Oh, what was I gonna say? Yes. So now here we have this face, which is where the pad goes, and that face, which is the edge of where the pad goes. But notice we have a manifold nest here. Did I fix that or did I not? I think, yes, I fixed that later on. Yep. I fixed it right away, I guess. So that's the edge of where the pad goes. Ah, yes, more fillets for acoustics and ergonomics this time. Chamfer, just so the border doesn't take up so much space. Ah, here we go. This gets into the deep. This is an interesting process here. Similar to the moving the clip area, but we're gonna take this whole headphone thing, this whole area. Give me a sec. Rotate this so I can freaking take basically that whole area, this whole area right here. I'll just hold it. We're gonna take that whole area and rotate it 5 degrees inward so that it bends out and has some pressure on your ears so it doesn't bend off the bottom of the ear. Plane and angle, split body right here. Oh, and right here. Oops. Can't avoid that. So we just combine it back together up here. Now there's the move. Oh, then we got a gap. So we revolve the gap 5 degrees, join operation. I'll go into this. So here you go. Angle 5 degrees, operation join. Okay. Calculates, done. What was this? Okay. So this is just refinements on, like, it looks like a really weird pair of headphones right now. And that made it look a little less weird. Those holes, I mean, I've seen them in every Sennheiser pair of Sennheisers I've ever seen. So I put them in. This is kind of roughly based on the HD280 Pros. And the HD380 Pros and the HD201s. Yeah. Because those were all pretty good headphones. I'm actually wearing a pair of 380 Pros right now. But, yeah. They're in okay condition. Now... Weird. Huh. Meshing weird. So now we have our little headphone area, headphone clip adapter thing for a VR headset. And we can mirror that and print the other side. That's so completely trivial compared to everything we just did. Now, this operation, no, not that one. Oh, I still have to do something here. So what we're gonna do is go right in. Oh no. Where's my offset face? If not there. Oh, there we go. There's more to it. Or not. Yeah, that I can all delete. Okay, now this extrusion was that. And that fill it around the edge for acoustics and strength. Offset, what was that? Yep. Okay, that was to make this cap fit looser, because with printers and it's just, oh man, just like with printers and everything, it just it's the dumbest piece of engineering ever. Not, well, there are dumber, but they are made for the parts to be expanded a little in surface offset. So you have to account for that when you put things together like this. Like right here, we're gonna have to radius 21 millimeters. Oop. Let's do this and go new offset minus 0.4 millimeters. Radius 21.4 millimeters. So as you increase the radius, a 21 millimeter radius circle will now fit in there. It is so weird. Like if you machine it, you can get ungodly tolerances. If you print it, you can't. So unless you use really special printing techniques, at which point you might as well machine it anyway. And just redo the design totally differently. Yay, into the sunset. Back. Okay. Yeah, I think that pretty much does it. Well, I should do a little bit more. Appearance. These are going to be plastic. It's an update. So our blue piece there, our white piece there. Should we make that red and white for Valentine's Day? Or green and white? No, red and white for Valentine's Day. So there we go. Here's our ever so complex design. Now watch how fast I can calculate all this. And I will note that, so if I just go here, so modify, compute all. Okay. Compute it all, or didn't compute all. I like to make a change in the very beginning sketch. Takes 10 seconds to update the whole thing. 10 seconds where you can't do anything and it'll freeze if you do. But well, it won't freeze, it'll just hang or something. Well, there's that.